You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. So, Lucas, tell us your full name. You're CEO of Loft Labs. So tell us a little bit about yourself.
Yeah, Lucas, Gentili, CEO at Loft Labs. Got the whole topic with virtual clusters started about 3 years ago. In April 21 is when we open sourced it. And I think our big announcement last time at KubeCon was hitting 40 million virtual clusters created. So I can definitely tell the open source project is taking off quite a bit. And we have some exciting integration to announce today.
It's a new age of virtualization, isn't it?
It is, yeah. I think, one analyst wrote about us, I think from Omnia, if I'm correct, that we're kind of building the VMware for Kubernetes. And I thought that was interesting to hear.
What's that?
I forgot. It's like 2 years ago.
Wow.
Was it Michael? I'm not sure.
VMware Kubernetes.
I do think VMware wants to be the VMware for Kubernetes.
Yeah, I imagine they do. But now, because the way I see it is like maybe you can then correct me by my description of a virtual cluster. That's what it is. It's a virtual cluster, right?
Yeah.
And so tell us what that is. What is a virtual cluster?
Yeah, a virtual cluster is essentially a Kubernetes control plane that runs inside a container that runs in another Kubernetes cluster. And that way you don't have to create, 300 different control planes on VMs. You actually can run them in containers, which is a lot more lightweight, faster to spin up.
Portable.
Even portable between clouds. It's really exciting, and they spin up in 6 seconds versus a real Kubernetes cluster. If you spin it up in EKS or GKE, it takes 30 minutes plus to start. So just that spin up time only gives you a lot of benefits. Some people start using it in CI now, is to spin up an entire fresh cluster for each CI run, something that's not even possible with a cluster just because it takes too long. And then drastically reduces the cost because you can share things in the underlying cluster. So let's say you need Istio in all of your clusters. What you can do with real clusters is obviously you have 300 clusters and you have 300 times Istio. Versus a virtual cluster, you can have one cluster, one Istio, and then 300 virtual clusters on top that share the same Istio. That's essentially where a lot of the cost savings and management overhead reduction kind of comes from.
So Lucas and I are here at eSpot, which is a gaming place. Yesterday this place was packed with kids.
I bet.
Mothers were standing watching, it was kind of funny. But this is where they're having the Cloud Native Rejects event here, which the New Stack is a sponsor of. And we love this event. It's a really good community event. And so I'm just happy to be here. So you're eve of KubeCon, and you're making some announcements here at KubeCon in Paris. Tell us a little bit about that.
Yeah, we're announcing Rancher integration for vCluster.
Okay.
And that will allow you to, Rancher, you can manage real clusters, right? And now you can manage virtual clusters with Rancher just like you can manage any real cluster, essentially. So, the Rancher community has been asking for this for about 2 years at this point. And, we thought, we had a pilot customer that's a pretty large company that has a big Rancher footprint. Mm-hmm. And they came to us and said, we have a problem too that the community has. And we're like, oh great, that's a great opportunity for us to partner up with them and kind of build it up. And today we're essentially announcing.
So tell us what the problems are that people face without the virtual clusters and what they want to do with the virtual clusters and what you're seeing people do with them now.
Yeah, it's essentially when there's two main use cases. It's either internal engineers need a lot of clusters. The demand for Kubernetes in a lot of Fortune 500 companies is just huge, right? There's new projects coming up, there's projects migrating to Kubernetes. In worst case, you have multiple Kubernetes clusters for the same application. So you have a staging cluster, your production cluster, your dev cluster for each one of your applications. And then you have 500 applications and boom, you have thousands of clusters, right? And that's a pretty huge problem at a lot of enterprises because all of these clusters are completely separate from each other, so you can't really share anything, right? You can't share Istio, you can't share any configuration, everything is separate. And the answer that everyone in the industry has towards this until we came up with virtual clusters is essentially fleet management. So they're saying, okay, we see this problem of things are out of sync and they're kind of separate from each other. So what we do is automation to keep it together. But we think the architecture is actually wrong. So we believe it's better to have a multi-tenant cluster instead of a single-tenant cluster. And suddenly you can share things.
What makes the architecture wrong? Is it a lack of sharing?
Yeah, it's a lack of sharing, essentially. Yeah, it's like when you think of the early days of Kubernetes, right? It was always about how many nodes can we pack in a cluster, how big can a cluster get, right? It was like 100 nodes, and then 1,000 nodes, and then 10,000 nodes, right? In the early days of Kubernetes, that was the goal. It was all about scaling. How can you run Kubernetes at scale? And then suddenly we forgot about that and started creating these little 3-node clusters everywhere. And that's really, Kubernetes is not designed for that. Kubernetes is actually really good at running at a large scale. But because it's super hard to share a cluster, and you have to set up a lot of things to make it work, it's not really isolated very well. That's why we resort to these little single-tenant clusters instead of having large multi-tenant clusters. And we're essentially saying, hey, let's do what Kubernetes is designed for. Let's create a shared large cluster and have virtual clusters as a virtualization layer on top that actually allows you to do the sharing in a secure way.
So let's talk about the evolution of clusters through the rise of Kubernetes, right? So people started with like just these monolithic clusters, didn't they?
Yeah, they did. Yeah.
And what happened?
I think what happened is, especially in the enterprise, they realized if you give a tenant and engineer access to Kubernetes, you have to really lock them down hard.
Yeah.
Because if you don't, then a lot of things can go wrong, right? And by things going wrong, I mean they can bring other tenants down, make the cluster unavailable, right? There's a lot of things that can go wrong. So for that kind of like resilience and availability purpose, there is a part of the organization, typically in IT, the platform team, right, that's responsible for spinning up and maintaining these clusters and installing Istio into it and Cert Manager and OPA, right, and all of this. And then there's the engineers who are just consuming Kubernetes API. And what they essentially want is unrestricted access to Kubernetes.
Right.
But you can't give that to them in a shared cluster because otherwise they couldn't bring the old policy agent down and then nobody can do anything anymore. Right. And so I think in an enterprise, that problem just becomes so big because there's like, 20,000 engineers that need access to Kubernetes. Then they started creating individual clusters instead. And these clusters are very tiny. A lot of them have like 3 to 8 nodes, right? Versus what Kubernetes actually is good at is running hundreds or thousands of nodes, right? But again, that's really not possible. And so in a lot of cases, they draw the boundary at like little 6 or 10 person teams, get their own cluster, or maybe get 2 clusters, one for production, one for pre-production. And that creates to this proliferation of clusters. A lot of, our customers have like 500 plus clusters today. The biggest one I've heard so far has over 3,000 Kubernetes clusters. That's a lot of clusters.
Tell me how much data that is, and how much, what illustrates the size of 3,000.
I think 3,000 clusters.
3,000 clusters.
3,000 clusters. Yeah, that's like. When you think about it, that's like 10,000 plus VMs, right?
Right.
Because typically you have like 3+ nodes in a Kubernetes cluster, right? That's a ton of CPU, right? The biggest problem of all of these clusters is because nothing is shared, there is a lot of idle time. So if this cluster is for pre-production and it's a relatively small one, nobody's using it on Saturday, nobody's using it at night, right? But scaling Kubernetes itself down is like you can scale applications in Kubernetes down to 0.
Yeah.
But scaling Kubernetes itself down to 0 is really hard.
Right.
Because then you gotta scale down a policy agent and you gotta scale down Istio and like all of these components. And that's not really straightforward. So I think that's one of the biggest advantages of virtual clusters, because virtual clusters are actually just an application running in an underlying cluster. So you can scale them down to 0. That means when you run a multi-tenant cluster and you have virtual clusters on top, these virtual clusters can go to sleep on a Saturday, Sunday, at night, right, when they're not being used. Sometimes, you can even spin up a vCluster per pull request, and it goes to sleep for the next 2 weeks until finally somebody reviews the pull request. Oh. And that makes a ton of sense, because that's patterns that weren't even possible beforehand with Kubernetes. You can spin up a cluster for pull request and just have it lay around for like
it's really expensive.
It's really expensive. You can't do that. A virtual cluster, you can do it. You can stand it up. You can run your integration tests. And let's say Yes,
It's just sitting there in the container.
exactly. It's just a single container.
And then you're just basically, when you need it, you're using it.
Yeah.
It's how do you trigger the virtual clusters? You do it through.
Yeah, so we have an interesting approach. We're essentially having kind of like a gateway, an API gateway. So in front of each virtual cluster's API server, there's this API gateway. So when you run a kubectl command, we see every request going through. And that means we can halt the request and say, hey, this virtual cluster is asleep. We'll spin it up real quick. It's just a container to store it, so it takes like 10 seconds or less. And then we let the request through. And we do the same thing with inactivity detection. So we're seeing, hey, you made that last kubectl request 30 minutes ago, so you're not using this anymore, so we'll turn it off.
Okay.
Yeah, and that saves obviously a lot of cost.
So that must save a lot of cost. I have a follow-up question about the evolution of cluster management. And from what I'm hearing you say is that as Kubernetes became more popular, and that non-sharing capability became a real hardship.
Yep.
And it required a lot of configuration just to get it set up.
Yep.
So is that when you came along? Did you come along around that time?
Yeah, pretty much.
What were you doing at that time? I mean, that really kind of then found you thinking this is a real issue.
Yeah, we built a PaaS at the time. I feel like everyone who builds.
Were you independent at the? Did you work somewhere else before?
That was essentially we pivoted as a startup.
Oh, you were a platform as a service?
Yeah, we were a platform as a service. Yeah.
What was the name?
DevSpace Cloud was a product.
Okay.
So this PaaS, we started in I think 2019. Mm-hmm. We had this open source project called DevSpace, and that's what I built in my current CTO Fabian. We built it in my previous company. We did cloud native consulting, a lot of work with Kubernetes. It was a services business, not a product business. And I had started in college, and we did all these exciting projects. Kubernetes, Docker came out, right? And we did every kind of contract that worked that was exciting. And we built this open source project, DevSpace, which is a developer tool for Kubernetes. And then we built a PaaS for it, so you could essentially get like a Heroku-like, shared piece of Kubernetes cluster, but it was just a namespace. It wasn't a virtual cluster yet. So we did this namespace as a service product. And while that was popular with like a lot of free tier users, hobbyists, right? It wasn't something any enterprise would build on. So it was really hard to commercialize. Wow. And then we realized, okay, so we got to do something else. We got to pivot, right? What do we do? What did we learn? Well, the thing we learned was how do you share a cluster? Because we literally had a cluster running with 1,000 people in it, right? And then we were like, okay, this sharing experience, like we have a lot of experience setting it up and making it secure, but what is missing? And what was missing was the autonomy of the individual user. Because, for example, CRDs, like if you wanted to install like Augur CD, for example, that's a global Kubernetes resource that you need, a CRD, application set, etc. And you can only install that with cluster-wide permissions. So none of our customers, in the past could create a Augur CD application. So we're like, okay, how can we fix that? And then the idea came of, what if we spin up Kubernetes inside containers and give that to people instead of giving the namespace to people? And then the idea of the virtual cluster was essentially born, and we pivoted towards that.
I'm looking at this story on my computer, and an interview I did with a team that helped develop KubeCon.
Yeah.
Is that similar?
So KubeCon is a little different, but I think for some use cases it is similar. So with KubeCon you can create VMs with Kubernetes. Mm-hmm. What you can create with us is a virtual cluster, not a virtual machine. Mm-hmm. But both of us do it through Kubernetes. So you use the Kubernetes API as the provisioning engine for it and to run the environment you want to run. But what they're focusing on is handing out virtual machines. We're handing out entire Kubernetes clusters.
Okay, great. That helps me understand the difference. So let's go back to then what we were talking about and like the evolution of clusters, and your company came along and you started building things. And I love this story about autonomy because that kind of is at the root of developer kind of happiness, right?
Yeah.
It's like people want autonomy, they want their independence, and that's been in our ageless struggle. But so now here we are at KubeCon. How does your news reflect the evolution of cluster management?
Yeah, it's interesting because obviously there's a lot of cluster management tools out there, right?
Yeah.
When we started, we were essentially saying, hey, you all are trying to do fleet management.
Yeah.
We think fleet management is the wrong approach, right?
Okay.
But now we're realizing people have fleets of virtual clusters that need management.
It's sense in our model.
Right. So essentially we now need to, provide a solution for like how do you install, applications in all of these virtual clusters and how you update these virtual clusters. And you need a tool for that. And we have a product for that as well, but we actually just want to spread the technology itself, the virtual cluster. That means we don't necessarily care which fleet management tool you want to use. That means we want to enable other tools, like Rancher in this case, to be able to manage virtual clusters the same way as you can manage real clusters. And obviously there's some plumbing to do and making sure that it's a little different than a real cluster. It's got to be treated a little differently. And that's why we essentially built that integration, because people are familiar, with the Rancher experience, especially as you said regarding autonomy, right? One of the great things about Rancher is a user can log in, can see their pods, can deploy a Helm chart, right? Like a non-expert Kubernetes user really appreciates the UI experience they have, right?
Yeah.
It's been around for years, people love it. And now with Virtual Cluster, you can exactly get that same experience. You don't have to learn anything new. Your team just handed you a Virtual Cluster instead of a real one, and ideally you don't even notice. You do the same things you would have done with Rancher previously in your Virtual Cluster as you did in your real cluster.
So what's the hook with Rancher then? How is Rancher has a huge user base, right?
Yeah.
So what is their environment and what does it not have? It doesn't have virtual clusters, but what does it have that enhances your offering too?
A lot. I mean, they have an app store with all these Helm charts, right? They do have ways for admins to configure certain things that are pre-installed in clusters, right? Like the whole Rancher Fleet, I think, is their product for fleet management. They have things regarding storage and monitoring built in the product. So if you want, you can obviously set all of this up with open source tooling yourself. Or you can just kind of use what Rancher kind of has baked in as best practices. And if you're already a Rancher shop, you probably already have that set up for your real clusters. Now you can just extend it to your virtual clusters. You import them into Rancher. We have a flow of importing them if you already have virtual clusters. And we also have a creation flow now. And the really nice part is, in Rancher, you typically don't potentially do the self-service for real clusters, because that's more of a, that's actually expensive to do, right? So a lot of enterprises don't allow their engineers to do that. Okay. But we have a self-service flow built into Rancher now with this integration that lets admins turn on self-service for virtual clusters. Because Rancher has self-service for namespaces already. And a virtual cluster is kind of in the middle between a namespace and a virtual cluster, and a real cluster. It's like as cheap as a namespace almost, it's just one container. But then it's as flexible and dynamic, and you get this full control if you had a real cluster. And now you can, as a regular user, you can sign into Rancher, you see that button, create virtual cluster, just as you see create namespace. And then you can spin up a virtual cluster there if your admin gave you the permission. Obviously with Rancher, you can also limit how many virtual clusters can everybody create, what are the resource kind of constraints in these virtual clusters. And then, it becomes a self-service shop for Kubernetes clusters.
What challenges does it bring to you to add this integration?
I mean, it was 6 months in the making, so definitely some R&D effort, but...
What did you have to do?
So we had to build two sides, right? So we have a platform that does all the orchestration and management for virtual clusters, and then we have the Rancher side. So we had to, on our end, make sure that virtual clusters are auto-imported and that you can sign in with your Rancher credentials, for example, because nobody wants to have like two separate logins, and it should kind of be seamless. You should click a button in Rancher, the UI pops open, you create a virtual cluster, and then you end up back in Rancher. So we had to adjust on our end some things, like callback URLs and rerouting you back and connecting to the Rancher system the same way. And then at the same time, we had to build components into the Rancher UI. They have a UI extension framework actually. So we use that extension framework, but there was a lot of experimentation of what can we do even with that extension, how can we, sometimes it's limited on what you can do, and we're like, how can we go a little beyond?
Right.
There was a lot of exploration and experimentation. We had a couple of, pilot customers on our end that were really interested in that. So we validated that user experience with them. And now it's, from today on, it's publicly available, so everybody can kind of check it out.
Well, good luck at KubeCon with this. I appreciate your time, and it's interesting new dimension. What do you think is next with cluster management? What do you think is on the horizon?
So I think one interesting concept for us is, when you think about virtual cluster as a next level of virtualization, and kind of, we talked about KubeWork, we talked about VMware, right? The thing that you could do with VMs is snapshot them and then move them to another physical host. And we're trying to make the same work for virtual clusters. Wouldn't it be cool if you can snapshot an entire Kubernetes cluster and then move it to a different environment, like to a different cloud provider region, for example?
Have we seen projects like that before?
I mean, there's like backup
VMware
solutions.
had one that came out of the startup that they bought, which is, my name is escaping me, Joe Beta's.
Yeah.
In any case.
Valeros, which mean the backing up. Yeah.
This is a little bit, but this is kind of an evolution of that?
Yeah, I think so, yeah. I think, when you think about a snapshot, really what matters is time.
Yeah.
And I think because we control the state of the virtual cluster, like literally like the etcd, right, the underlying state, we can snapshot the cluster at a deeper level. Like Valero is they connected Kubernetes API to save objects.
Yeah.
So they have to go through these objects.
Yeah.
Versus we can snapshot the underlying data store. We can move it, which hopefully is a lot faster. That's a big R&D topic for us right now.
So what would that provide the end user? What would that do?
I mean, ultimately, the dream would be real-time migrations. So while your application is running, you migrate over
to another service.
To another server, to another cloud, right? Obviously, to another cloud is the biggest challenge, right? Because then you have like certain other external APIs, databases,
right, that
used,
becomes an
right?
issue. But even internally, right? Like it, yeah.
That's interesting. It's an interesting concept. The other one, so far we've been speaking about slicing up a real cluster into virtual ones. But now you could also imagine a virtual cluster spanning multiple clusters. That's the other interesting concept we're investigating. Right? We're
spanning multiple clusters. Because you could copy it, snapshot it, and then apply it to all those other clusters. Why would you do that?
So think about for example, right now cloud providers typically restrict you to one region for your Kubernetes cluster. Right. So you can't have a global Kubernetes cluster. It just doesn't exist. Virtual cluster, technically that could exist. Like we could say, hey, if you're deploying a pod, we look at where can this pod run most economically, and that's where we schedule it to. Or we can say, hey, this is a cluster, a virtual cluster that spans a cluster in your private cloud and a cluster in AWS. And then we kind of bridge the gap, and the experience is exactly the same for the user. I think that's something super fascinating, but that's more down the road topic.
Well, Lucas, thank you so much for your time. We appreciate it.
Yeah, thank you for having me.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.